In this video, we are going to prove some stuff that is necessary later. Um, so, first of all, let's revisit our criterion for the Lucas-Lehmer primality test. So, if you remember, we basically said that 2 to the power of p minus 1 has to divide s of, well, basically s n minus 2. So, if I have some Racine number, right, and I want to check if it's prime or not, what I do is I check, does it divide s in minus 2 or s in minus 2. Those were our criterion. So we are going to basically we're assuming that it does divide. We can basically, what we're gonna do is we're gonna prove some criterion that will allow us to go further, and eventually what we'll do is we'll prove that if this is true, if it does divide, if 2 to the n minus 1 does divide s n minus 2, like it's saying right here, if this is true, then that means 2 to the n minus 1 will end up being prime. So also there is a slight technicality that I've been overlooking in my previous videos. Many times I've said a Mercian prime is 1 less than a power of 2. Technically, it's 1 less than a power of 2, where that's 2 is raised to a prime number. Like 2 to the 4 minus 1, previously have said it's a Mercian number. Technically, it's not a Mercian number because 4 is not prime. But for the sake of simplicity, I'm going to pretend that a Mercian number is just 1 less than the power of 2, and I think all the arguments will still hold. But yeah, so now you know the true definition of a Mercian number. Sorry about that. Okay, so back to this. So if I want to figure out whether or not this Mercian number is prime or not, I have to figure out, does it divide this? And I'm assuming if it does. So what we're gonna do is we're gonna So what we're gonna do is we're gonna say, if this is true and this isn't prime, it's gonna lead to a contradiction. Therefore, if this is true, it has to be prime. So that'll be one part. That means if our criterion are true, then therefore it is a prime. And then the second part will be, if the criterion are not true, it's not a prime. But for now, we're going to do this. If the criterion are true, it is a prime. So for the next few videos where I'm doing this part of it, I'm going to prove that. Or I'm going to be assuming that the criterion are true. So the criterion is this. I guess I'm going to write down the definition of the S because I don't have it written here. Okay, I have just written the definition. So these are a criterion for 2 to the n minus 1 being prime. So now what we're going to do is, assuming this, we have a few things. So the first thing we can do is we can say, okay, well, this divides that, right? Which means this is a multiple of that. So let's call that multiple k. So okay. So basically, we're assuming that this is true. Therefore, this divides that, which means this is a multiple of this, and we're going to call that multiple k. Okay. So now what we have is, and remember from our previous video, we derived an explicit formula for this. So I'm going to substitute that in, because in the last few videos we basically derived an exact formula for s, for Sn minus 2 or Sn or something. So that's what we did last video. So because we proved that formula last video, in this video I am going to use that formula. So that's what I'm going to do right now. I'm just going to plug in that formula that we figured out last video. Yeah. Sorry. Okay. So here I've just plugged in the formula we found last time. If you remember our formula, this is it. W is 2 plus the square root of 3, and W bar is 2 minus the square root of 3. I'm going to write that down just in case people forget it and then they need to remember it. Okay, so I have just written that formula down right here, or sorry, the definitions of W and W bar, and I've substituted our formula from last time. So now we have this equation. So next, we are going to square. No, sorry, we're not going to square both sides. We're going to do something where we are going to multiply by this one right here. So we're going to multiply each side by this right here. So okay. So what we're going to do is we're going to multiply both sides by this right here. This one. All right. So when we do that, we get By the way, if you're wondering why I keep glancing over, I don't like. There's some formulas that I don't have completely memorized, so I'm reading it from Wikipedia. So, yeah, so that's why I keep on looking just to make sure I have like the formulas right and that stuff. So, right. Yeah. Oh yeah. Okay. It looks a little off. Okay. So I've multiplied this equation by W to the 2 to the n minus 2. So this one is just that squared because we had this and we just multiply it by itself, so now it's squared. This one we had W bar to the 2 to the n minus 2 times W to the 2 to the n minus 2. And so we're just multiplying that. And over here we have what we had before, and we're just multiplying by that. So the first thing to notice is that similarly to last video, when we were proving the explicit formula, which is what we did in the last video, we can basically we have W to the power and W bar to the power. So this is just equal. It's the same power. So it's just W times W bar to that power. And if you remember from last video, we figured out that W times W bar is equal to 1. So therefore it's 1 to some power, which is just equal to 1. So therefore this is equal to 1. If you're a little bit confused, just remember what we did last video. It's incredibly similar. So yeah, so that's why I'm not writing it down, because that's what we did last video basically. Oh yeah, and then the second thing to note is that this right here, also very similar to what we did last video, this 2 can go over here, and you have W to 2 times 2 to the n minus 2, which is just 2 to the n minus 1. So that's pretty similar to what we did last time. So hopefully if you understood it last time, you understand it this time, because they're very similar. Yeah. So I'm just going to simplify this a little. Yeah. Alright. So what I've done is we talked about how this right here was 1, and this I basically became n minus 1. And so now what I'm going to do is I'm just going to bring this 1 over, subtract 1 from each side. So we get okay, let's see. Okay, so this is the formula right here. This right here, W to the 2 to the n minus 1 is K times 2 to the n minus 1 times W to the 2 to the n minus 2 minus 1. Yeah, I'm just gonna make that 1 look a little better at the very end. So yeah, that's the formula we have derived in this video. In the next video, I think we're gonna talk about groups and group theory. I hope you enjoy the video. Thank you for watching. Yeah, thank you. Bye.